Dear students of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today, the related time rates. If we have a relation between x, y, z, and so on, then the differentiating with respect to time t, we get a relation between dx dt, dy dt, dz dt, and so on. For example, when a circular lamina is exposed to a heat source for a period of time t second, the two variables a and r, a is the area of the lamina and r is the radius of the lamina, change over time. Then we have a function of time, and they are related by the relation a equals by r power 2. A equals by r power 2, the area of the circle. Then, by differentiating both sides with respect to time t, we get the dt equals by the constant, then the derivative of r power 2 with respect to the time t is 2r dr dt. Then the adt equals 2 by r dr dt. The differentiation of both sides of the relation above with respect to the time leads to a new equation relating between the related time rate of each variable, a and r, and it's known as the equation of the related rates. Dear students, the time rate is positive is the variable increase with the increase of the time t, and the time rate is negative is if the variable decrease with the increase of the time t. The related time rate related between two variables. Then if we have the relation between a and r, then the a dt equals 2 by r dr dt. If the rate is positive, then the variable increase. If the rate is negative, then the variable is decrease. And which of the following rates is positive or negative? Expansion, diverge, molding, accumulation, increasing is positive. Shrinking, approaching, leaking, melting, decreasing is negative. Now, the first example. A point moves on a curve whose equation is x power 2 plus y power 2 minus 4x plus 8y minus 6 equals 0. If the rate of change of its x coordinate with respect to time t at the point 3 and 1 equals 4 units per second, find the rate of change of its y coordinate with respect to the time t. Now we have dx dt equals 4 units per second. At the point 3 and 1, then x equals 3 and y equals 1. What is the derivative or the change of its y coordinate with respect to time, which is dy dt? Now we have the relation x power 2 plus y power 2 minus 4x plus 8y minus 6 equals 0. By differentiating both sides with respect to the variable t or the time t, we get the derivative of x power 2 is 2x dx dt plus the derivative of y power 2 is 2y dy dt minus the derivative of 4x 4 dx dt plus the derivative of 8y with respect to t is 8 dy dt. What about negative 6? Negative 6 is a constant. The derivative of any constant number equal 0. Then we can take dx dt as a common factor. Then between two brackets 2x minus 4 multiply dx dt plus 2y plus 8 multiply dy dt equal 0. We know that dx dt equals 4 and x equals 3 and y equals 1. We can substituting in this relation, then 2 multiply 3 minus 4 between two bracket multiply 4 plus 2 multiply 1 plus 8 between two bracket multiply dy dt. The first term is 8 plus 10 dy dt equals 0. Then 10 multiply dy dt equals negative 8. Then by dividing both sides by 2, 5 dy dt equals negative 4 and dy dt equals negative 4 over 5 units per second. Now we move to the next example. A stone fell in a motionless lake and a circular wave was generated. If its radius length increases at a rate of 4 centimeters per second, find the rate of increasing of the surface area of the wave at the end of 5 seconds. We have circles, the radius r, and the rate of change of the radius equals 4 centimeters per second. The radius is increased, then the rate is positive. At t equals 5, then the radius equals 20 centimeters. 5 times 4 equals 20 centimeters. Then what is the rate of change of dA with respect to the time t? The related time rate of the area of the circles. Now, dear students, what is the relation between the area and the radius of a circle? Yes, the area A equals by r squared. We can differentiating both sides with respect to the time t. The derivative of A is dA dt equals pi is a constant, and the derivative of r power 2 is 2r dr dt. Then dA dt equals 2 by r dr dt. At t equals 5, the radius equals 20 and the rate equals 4. Then dA dt equals 2 multiply by multiply 20 multiply 4. Then dA dt equals 160 by centimeter per second per 2 per second. 160 by centimeter per 2 per second is the rate of increasing of the area of the wave at the end of 5 seconds. Dear students, we have another solution. We know that dr dt equals 4 centimeters per second and the time t equals 5. Then the radius in terms of t equals 4t centimeter, because r equals r naught plus dr dt multiply t. Then r equal 0 plus 4t, or r equals 4t. And what is the rate of change of A with respect to time at this second? we have A equals by R squared. The area of the circle equals by R squared. And we can write this relation as A equals 16 by T power 2. By use the time T. For T power 2 equals 16 T power 2. Then the relation now between the area A and the time T. By differentiating both sides with respect to the time T, the derivative of A is dA dt equals the derivative of 16 by T power 2 is 32 by T. At T equals 5, then dA dt equals 32 by multiply 5, then dA dt equals 160 by centimeter power 2 per second. Now we move to the next example. A known mass of gas with a constant temperature whose volume decreases at a constant rate of 2 centimeter power 3 per second. If the pressure is inversely proportional to the volume and the pressure equals 1000 gram weight per centimeter power 2, when the volume is 250 centimeter power 3, find the rate of change of the pressure with respect to time when the volume of gas is 100 centimeter power 3. We have dV dt, the rate of change of the volume equals -2 centimeter power 3 per second. Negative because the volume decreases at a constant rate of 2 centimeter power 3 per second. And P equals 1000 gram weight divided centimeter power 2, or 1000 gram weight per centimeter power 2. When the volume equals 250 centimeter power 3, what is the rate of change of the pressure with respect to time? We let the pressure equals B and the volume equals V. What is the relation between P and V? P varies as 1 over V. Then P equals constant over V. C is a constant and not equal 0. Cross multiplication. Then PV equals C, where C is a constant. Now, when P equals 1000 gram weight per centimeter power 2, the volume V equals 250 centimeter power 3, and we know that PV equals 250 multiply 1000 equals 250,000. From the relation P times V equals C, we differentiating both sides with respect to the time T. Then dB dt multiply V plus dV dt multiply P equal 0. We have product of two functions, P and V. Derivative of P with respect to time is dB dt multiply the second plus the derivative of the second dV dt times the first P equals the derivative of the constant C equal 0. When V equals 100 centimeter power 3, the pressure P equals 2500 gram weight per centimeter power 2. Then dB dt multiply 100 plus -2 multiply 2500 equal 0. Then dB dt times 100 equals 5000. Then dB dt equals, by divided both sides by 100, then dB dt equals 50 gram weight per centimeter power 2 per second. Another example. an isosceles triangle whose base length is 20 root 3 centimeter if the length of the two equal legs decreases at a rate of 3 centimeter per hour. Find the rate of decreasing the triangle surface area at this moment, which the length of the two equal legs is equal to the base length. Now we have an isosceles triangle ABC, and we let the length of the two legs is x, and we have the length of its base BC equals 20 root 3 centimeter. The rate of decreasing of the length of the two legs equals -3 centimeter per hour, and the length of the base B equals 20 root 3 centimeter. What is the rate of change of the area with respect to time? We know that the surface area of any triangle equals half base times height. Then the area equals half times the length of its base is a constant number which equals 20 root 3. Multiply the height. The height equals square root of x power 2 minus 10 root 3 all power 2 from the Pythagoras theorem. Then A equals 10 root 3 multiply square root of x power 2 minus 300. By differentiating both sides with respect to the time t, we get dA dt equals 10 root 3 multiply 2x, which is the derivative of the function under the root, over twice the root over 2 times square root of x power 2 minus 300 times dx dt, which is the derivative of x with respect to the time t. Then dA dt at x equals 20 root 3, x is the length of any leg, then this side equals the length of the base of the triangle equals 20 root 3 centimeter. Then dA dt at x equals 20 root 3 equals 10 root 3 multiply 20 root 3 over square root of 20 root 3 power 2 minus 300 times -3. Then dA dt equals -60, and we can write the rate of change of the area of the surface area of the triangle equals -60 centimeter per 2 per hour, or the decreases of the area equals -60 centimeter per 2 per hour. Now we move to the next example. If the gas leaks from a spherical balloon at a rate of 20 centimeter per 3 per second, find the rate of change of the balloon radius length at the moment which the radius length is 10 centimeter, and find the rate of change of the balloon external surface area at the same moment. We have a spherical balloon and the gas leaks from it. The volume is decreased with the rate 20 centimeter per 3 per second. We can write dV dt, the rate of change of the volume with respect to the time, equals -20 centimeter per 3 per second. At r equals 10, what is the value of dA dt? dA dt is the rate of change of the surface area or external surface area with respect to the time t. Now, what is the relation between the volume and the radius? We know that the volume of the sphere equals V. V equals 4 over 3 by r power 3. By differentiating both sides with respect to the time t, we get dV dt equals 4 over 3 by multiply the derivative of r power 3, which is 3r power 2 dr dt. Then dv dt equals 4 by r power 2 times dr dt, where r equals 10 centimeter and dv dt equals negative 20 centimeter power 3 per second. Then negative 20 equals 4 by multiply 10 power 2 dr dt. Then the rate of change of the radius length dr dt equals negative 20 over 4 by times 100 power 2, and we can write this relation in the form negative 1 over 20 by centimeter per second. Now we have the related time between the radius and the time, or dr dt. Now what is the area of the sphere? The area of the sphere, A equals 4 by r power 2. By differentiating both sides with respect to the time t, then dA dt equals 4 by multiply the derivative of r power 2. The derivative of r power 2 with respect to time t equals 2r dr dt. Then dA dt equals 8 by r dr dt. Now dA dt at r equals 10 centimeter equals 8 multiply by multiply 10 multiply the rate of change of r with respect to the time t, which is negative 1 over 20 by. Then dA dt at r equals 10 equals negative 4 centimeter power 2 per second. Another example. A balloon rises vertically from point A on the ground surface, and apparatus is placed to follow up the motion of the balloon at point B at the same horizontal plane of point A and distance 200 meters from it. A moment the apparatus observed the elevation angle of the balloon to find it by over 4, and it increases at a rate of 0.12 rad per minute. Find the rate of the balloon elevation of this moment. We have a balloon rises vertically from a point A on the ground, and at a point B there is a man observed the motion of the balloon. Then the height of the balloon h is variation, and the measure of the angle of theta or the angle of elevation is change with respect to time. Then d theta dt equals 0.12 rad per minute at theta equals pi over 4. Then what is the relation between theta and the height h? Tan theta equals opposite over adjacent equals AC over AB. Then tan theta equals h over 200. We can write this relation as h equals 200 multiply tan theta. Now we have a relation between the height h and the measure of the angle of elevation. By differentiating both sides with respect to the time t, then dh dt equals 200 multiply the derivative of tan theta with respect to time. The derivative of tan theta is sec power 2 theta d theta dt. And we know that the rate of change of theta with respect to time equals 0.12, and the measure of the angle at this moment equals pi over 4. Then dh dt at theta equals pi over 4 equals 200 multiply sec power 2 pi over 4 multiply 0.12, which equals 48 meter per minute. And by this example, we come to the end of our program today. Till we meet again, it's goodbye.